Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Pathuchezo Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we are going to be learning under the knowledge area, energy and change. The topic is series and parallel circuits, and then the subtopic, which is our main area of focus today, is series circuits. Now, let's go through the lesson objectives. At the end of the lesson, you should be able to define series circuits, explain how components are arranged in series circuits, and draw diagrams of series circuits. All this is sourced from your CAPS document on page 49. Now, pre-knowledge. What did we learn before today? In grade 5 and in grade 6, you were introduced to circuits and current electricity. So we're building from there. We're adding more knowledge from what we learned back in grade 5 and 6. Now, let's go into the baseline activity. Number 1, draw a simple circuit diagram that has an open switch, a light switch, conducting wire, and a cell. Number 2, what will happen in the circuit if the switch is turned on? Number 3, draw the symbols of the components on the board. A cell, closed and open switch, light bulb, and resistor. Take 5 minutes to quickly write these 3 questions, and then after 5 minutes we are going to go through the solutions together. Don't forget to send in your responses and any questions you may have to 079 578 2908. See you after 5 minutes. Welcome back, learners. Now let's go through the solutions for the questions. So you were required to draw a simple circuit diagram that has an open switch, a light bulb, conducting wire, and a cell. So there is the diagram. We've got our cell, conducting wire, our light bulb, and our switch. And then there's a second question. What will happen if the switch is turned on? What will happen if the switch is turned on? What does it mean? If we close the switch and if we close this gap, what is going to happen? The light bulb will switch on. The light bulb will switch on. All right. Now take 1 minute, take 2 minutes to quickly draw the diagram and then copy question 2. Welcome back, learners. Let's answer question 3. Draw symbols of components on the board: a cell, closed and open switches, light bulb, and resistor. So there are the symbols. The open switch, or the switch in the off position, this will show you this will be having a gap, a bulb, a circle crossed in the middle, a cell, one line and one long line and a one shorter line, a switch in the on position, which means it is closed, the gap is closed, then resistors, a rectangle or a zigzag. With different textbooks, you will see different representations of resistors, so that's why I added both symbols. Okay, now take 2 minutes to copy down all these symbols. Welcome back, grade 8 learners. Now let's move on to terminology. So these are the terms we're going to come across during the course of the lesson. So I want us to learn each term. The first one is series circuit, which is also the title, the subtopic. This is a circuit in which the current flows in one path, or rather along one path without branching. Along one path without branching. Resistor, this is a material's ability to block or oppose the flow of electricity. Load, any device in a circuit that uses energy that the current delivers, Okay. Now, series circuits, we have defined them under terminology, but what are they? Let's describe them, let's define them, and let's explain them. So a series circuit, once again, is a circuit in which current flows along one path without branching. So this is very important. This is how we describe series circuits. This is a circuit in which the current, remember, current is flowing in a circuit. Remember, we learned about simple circuits in our previous lesson. Now, so in a series circuit, this particular type of a circuit, the current is flowing along one path without branching, so it's following exactly one path. So a series circuit provides only one pathway for the electric current to pass through it, so there are no other pathways. If we look at this diagram that I've just pulled up, so this is a circuit. We've got resistor 1, resistor 2, resistor 3, and we've got our power source or our energy source. So our current is flowing in one pathway. It's flowing in one pathway. There are no other branches, there are no other routes, there are no other alternative pathways. So the electric current is flowing along one pathway, flowing through each and every component that is connected in this circuit. So all the current is going to flow through each of the components without dividing. So the amount of current, so because it is flowing through each of the components without dividing, this means that the amount of current is the same through each part or component in the circuit. So when we connect the components, we say they are connected in series because they are connected end to end, one after another, without any branches or without any alternative pathway. And the current will be flowing through each and every component, and the amount of current that is flowing through each part or each component is the same. It is the same. So if we look at this circuit, this series circuit, so these components, component 1 and component 2, component 3, component 4, they have one pathway. There's only one pathway that is being followed here. And the current is the same through each part or each component in the circuit. Bulb 1 and bulb 2. So the current is the same here, the same here, the same there, and the same there. So it is the same. Now, if let's say we only had one bulb or one component, if another component is added to a series circuit, then the current in the entire circuit is going to be affected. It is going to be affected. How will it be affected? It will be affected because the total resistance increases. The total resistance increases. Remember, resistors, they oppose the flow of current, or they stop, or they try and hold, they oppose the flow of current. So adding another light bulb to a series circuit that already has maybe 2 light bulbs, and adding a third one is going to increase. It's going to increase the total resistance. What is going to happen to the current when resistance increases? So when resistance increases, the current decreases. And how do we know that? We use a simple device that is called an ammeter. An ammeter is a measuring device that is used to measure electric current within a circuit. And there's a special way of connecting an ammeter. It is always connected in series. So it has to be connected in such a way that all the current it has one pathway, so it is connected in series. So now that we know the general structure of the series circuit, let's draw a series circuit. Let us draw a series circuit. So we said in a series circuit, all components are connected end to end, forming a single path for the current to flow. Let's look at the first example. Let's look at the first example. So this will be the drawing, or what you see. We've got light bulb 1, light bulb 2, we've got our energy source, and we've got our pathway or our conducting wires. So when we draw our series circuit, we're using symbols. So this is the symbol for the light bulbs, this is the symbol for the conducting wire, and this is the symbol for the energy source. So this is how we draw a simple circuit, rather a series circuit. We want to draw these components exactly the way they are, connected in an end-to-end format, in an end-to-end way, forming a single path for current to flow. So current is flowing using a simple path. It is flowing using a simple path. I don't see any other branching routes. Now let's look at a second drawing. We are still sticking to the end-to-end structure, how the components are going to be connected. They're going to be connected end-to-end. Here's an example. So this is what we see. We see a cell, we see conducting wires, and we see bulb 1, bulb 2, and bulb 3. Okay, so but how are they connected? So this is the positive and that's the negative end. So we've got bulb 1, bulb 2, bulb 3. They're all connected end to end, and there is only one pathway that current is going to follow. It's going to follow one pathway. It is going to follow one pathway. There are no other branching pathways. Now, let's see if you can draw this series circuit. So we already know how to draw different symbols of different components. Now we know that components in a series circuit are connected end to end. So let's draw these series circuits using symbols. To draw a series circuit with the following components: 1.1 conducting wire, 3 cells, ammeter, bulb, and a resistor. Conducting wire, 1.2 conducting wire, 1 cell, ammeter, and 2 bulbs. 1.3 conducting wire, 2 bulbs, ammeter, 1 cell, and a closed switch. Take 5 minutes to draw these 3 series circuits. Use symbols. Welcome back, grade 8. Let's answer, or rather, let's draw. Conducting wire, 3 cells, ammeter, bulb, and a resistor. There we go. So remember, 3 cells make a battery, so you can write cells, or you can write battery. There we go. We've got our 3 cells there. We've got our ammeter, our lamp, and our resistor. Take 2 minutes to draw this diagram. Welcome back. Now let's draw the second diagram. Let's draw the second diagram. So we needed to draw conducting wire, 1 cell, 1 ammeter, and 2 bulbs in a series. Okay, so we've got bulb 1, bulb 2, our ammeter, 1 cell, and conducting wires. Now take 2 minutes to copy down this diagram. Let's draw the third diagram. We need conducting wire, 2 bulbs, ammeter, 1 cell, and a closed switch. Right, so here is our closed switch and our ammeter, our 2 bulbs. There's bulb 1, bulb 2, conducting wire. And what's missing? What's missing? 1 cell. Okay, take 2 minutes to quickly copy down this series circuit. Welcome back, learners. Now let's continue with our lesson. Now that we know how to draw a series circuit, so let's learn more about series circuits. The simplest circuit would be one that has only one resistor. Remember, when we were learning how to draw a simple circuit, the simple circuit had one resistor. That one resistor was in the form of a torch bulb. It was in the form of a torch bulb. So our simple circuit had an energy source, which was a cell. It had conducting wires, and it had a switch and also a torch bulb. So that is a simple circuit. A simple circuit would only have one resistor. Now, to estimate the amount of resistance, for example, that a torch bulb would offer or LED light can offer, this is these two resistors, either torch bulb or LED. Right, the relative brightness will be used. So this is how we would estimate the resistance of a torch bulb or LED light within a circuit. So it would be relative to the brightness of the bulbs. So the brightness of the bulbs will indicate the amount of current that is flowing through a circuit. Right, so here we've got a circuit, a series circuit that has 3 resistors, bulb 1, bulb 2, bulb 3. So to estimate or to try and check the relative resistance, we check the brightness of the bulbs, the brightness of bulb 1, the brightness of bulb 2, the brightness of bulb 3, how the brightness is affected when some more or extra resistors are added or extra resistors are added. Scenario: if we begin with a circuit that only has one resistor in the form of a light bulb. So in other terms, if we begin with a simple circuit, the total resistance is going to be small, because the only resistance that is being offered is by this one light bulb. So the one light bulb is the one that is offering resistance, so resistance is going to be relatively small. Now, the position of the resistor in a series circuit does not influence the amount of resistance in a circuit. You need to remember that. Remember, in a series circuit, resistors are connected end to end, one follows the other along one pathway. So the effect, or rather the position of the resistor in a circuit, does not influence the amount of resistance. You need to remember that. Now, if the number of components stays the same, for example, if we stay with one light bulb and we don't add anything, we don't add another component onto the circuit, the resistance is going to stay the same. So, which means if the total number of components stay the same, the resistance will stay the same. This is with regard to series circuits. The position of a resistor within a series circuit does not affect the amount of resistance in a circuit. So you can swap bulb 3 with bulb 1, or swap bulb 1 with bulb 2, it doesn't affect the resistance. And if there's only one resistor in that particular circuit, then we know that the total resistance is going to be small. So here we've got a circuit, and that circuit has one component. That circuit has one resistor. Sorry, that circuit has one resistor. We've got other components, conducting wires, our energy source, there's a cell there, and we've got an ammeter. It's measuring our current. We've got a current of 1.20 amps or amperes. Okay, so this simple circuit, or the circuit, has one resistor, which is one torch light bulb. So we're going to use the length of these yellow lines, or these rays that are emanating from the bulb, as brightness. So they are quite long, and the blue circles with the minus sign in them, that is the flow of current. So current is flowing there. So the resistance is minimal, and the total current measured in the circuit is 1.2. If things change in such a way that more resistors are added, if we're going to add more resistors into the circuit, there's going to be an extra load. So the load on the circuit is going to increase, because the total resistance would have increased, would have added more resistors. So the types of the resistors that we're adding in this particular case are the light bulbs. So we're adding light bulbs. So this means that the overall current in the series circuit is going to be reduced. Remember, previously we said the more resistors we add, it reduces the total current, or the current in the series circuit. So it will be reduced, or it will be decreased. And the effect of the reduced current is going to be seen where? By the light bulbs. What will happen to the light bulbs? They will become dimmer. The light bulbs will become dimmer. Let's start off with scenario A. With scenario A, we said in our circuit there's only one resistor, that light bulb, and we're measuring brightness by the length of the yellow lines. So that is a representation of the brightness of the bulb, of this one resistor. And look at how fast moving the current is flowing, represented by the blue circles with the minus sign. And the overall current is 1.20A. Now, if we add more resistors, so we had one light bulb, now we've added number 2, now we've added number 3, so we've added 2 more resistors. So we are saying that the overall current is going to be reduced. Has it been reduced? Let's check the measurement on the ammeter. There, it is now at 0.40 amps. Now, is the current still flowing as fast? No, it isn't. Actually, the blue circles are actually flowing slow and slower while they are encountering more and more resistance. Is the brightness still as bright? Are the lines still as long? Are the lines that represent the brightness still as long? No, they are now shorter. So what has happened in this particular case? By adding more resistors to the series circuit, we have increased resistance, but current has decreased, or current has been reduced, as shown here on the ammeter. We now have a lower current of 0.4 amps. of 0.4 amps. So that is one of the disadvantages of using a series circuit. The more resistors you add, it means current is reduced, and we can clearly see it here by the change or by the dimming in brightness of the bulbs, by the dimming in brightness of the bulbs. So if a light bulb breaks or a component is disconnected, the circuit becomes open. So in a series circuit, if one of the light bulbs pops or it breaks or it becomes disconnected, what's going to happen? The current is not going to flow, and as a result, the whole circuit is affected. Remember, current not flowing means there is a gap somewhere. So if a component breaks, or if a light bulb is removed from one of the sockets there, if it is removed from one of the holders, then which means we're now having an open circuit. And what does it mean when we have an open circuit? When we have an open circuit, it means current is no longer flowing, and now all the other light bulbs, so if we remove light bulb 1, light bulb 2 and light bulb 3 are going to be affected. Current is not flowing, so they are not going to switch on, they will switch off. If bulb 1 pops, bulb 2 and 3 will switch off. If bulb 1 is removed, bulb 2 and 3 will switch off. So that is another disadvantage of a series circuit. So if a light bulb breaks or a component is removed, the circuit will become open, no current will flow. So it will affect all the other components within the circuit, and they will not function. They are not going to function. Another thing about a series circuit is the current is the same. So it flows at the same strength everywhere. It flows at the same strength everywhere in a series circuit. Why or how come? This is because there is only one pathway. Remember, that's how we said a series circuit only has one pathway through which current is flowing. So there's only one pathway. So because of that, because of the fact that there's only one pathway, it means that the current flows at the same strength everywhere. We say the current is the same at all points in a circuit, which means if we measure a current of a total of 5 amps, current here is equal to 5 amps. The current over here is also equal to 5 amps. The current over here is also equal to 5 amps. And the current over here is also equal to 5 amps. So in this entire circuit, the current is flowing at the same strength. At all points in the circuit, the current is measured at a total of 5 amps at each and every point that is in the circuit, at each and every point in the circuit. Now, if we add more resistors, we said the lights will dimmer. So if we add more resistors in a series, or we add them in series end to end, one after another, the light bulbs are going to dimmer. Why do they dimmer? Because of the decreased current. Remember, current is the same at all points in a series circuit. So adding a resistor at any point in the series circuit is going to reduce current. And if they happen to be light bulbs, those light bulbs are going to become dim because the whole circuit is affected by any changes that happen to any component that is within the circuit. A position of a resistor does not mean anything. It doesn't affect the amount of current. It doesn't. A position of the position doesn't affect, but adding a resistor does affect. So the more light bulbs are added, it means that more resistance is being added, resistance to the flow of current. Let's focus on these blue circles, the flow of current. Do you see the pace in A and the pace in B is quite different? The pace in the two is different. In A, it's a much faster pace because there's less resistance. In B, it's a much slower pace because there's more resistance. The brightness of the bulb in A is very bright. There's only one resistor, so there is more current flowing through the circuit. In diagram B, the current is less. Why? Because there are more resistors. There's one, there's two, there's three resistors that have been added to the circuit. So they will be affected. And we see this by the dimming. We see this by the dimming, which brings us to our second activity. Number one, if the number of bulbs in a series circuit is increased, how will this affect the brightness of bulbs? Number two, draw the symbol of an ammeter. Number three, a circuit diagram consists of two cells connected in series, a switch and a light and a bulb. An ammeter is also connected in the circuit diagram in such a way that it can respectively measure current. 3.1. What energy conversion will occur when energy moves from the cell through the conducting wires to the light bulb? Alright, take 5 minutes to do this activity. Then after 5 minutes, we will do the solutions together. Don't forget to send in any questions you may have and solutions to the activities to 079 578 2908. Welcome back, learners. Let's answer these three questions. If the number of bulbs in a series circuit is increased, how will this affect the brightness of the bulb? It will decrease or they'll become dimmer. They will become dimmer because of the increased resistance. Draw a symbol of an ammeter. It is a circle with the capital letter A in the middle. Number 3, a circuit diagram consists of two cells connected in series, a switch, and a light bulb. An ammeter is also connected in the circuit diagram in such a way that it can respectively measure the current. What energy conversion is going to occur when energy moves from the cell through the conducting wires to the light bulb? There we go. It is chemical energy to kinetic energy to light bulb or heat energy. So the chemical energy is from the cell. Remember, the energy is stored as kinetic energy, which is then converted to kinetic energy, light energy, or heat. Remember, with the bulb, we always say light or heat energy. Take 2 minutes to quickly copy down these corrections, and after 2 minutes, we will continue. Welcome back, learners. Now let's wrap up our lesson. What did we learn today? We learned that in a series circuit, right, a series circuit provides only one pathway. It provides only one pathway for the current to pass through. So the current is going to pass through each and every component that is in that series circuit. And the current is the same everywhere in a series circuit. At any point in the series circuit, the current is exactly the same. But each time we add a resistor in a series circuit, the current or the overall current is affected because the current is the same everywhere, so which means the overall current is going to be affected each time. And the light bulbs will become dimmer when we add more. When we add more light bulbs to a series circuit, the light bulbs are going to become dimmer. They will become dimmer. Why? Due to the decreased current. They will become dimmer due to the decreased current. And as we increase the number of light bulbs, what are we doing? As we increase the number of light bulbs, it means that the resistance has increased, and this resistance will resist the flow of current, hence the light bulbs will become dimmer. So when I showed you that diagram with a circuit that had one resistor and the other circuit had three resistors, the overall brightness was dim for the one that had three resistors or three light bulbs, and the overall brightness was very bright for the one that had just one resistor. So in a series circuit, all of the current is the same everywhere in the entire circuit. At any point, At all the points, the current is the same. Adding more resistors decreases the current and increases the resistance. Increasing resistance is going to decrease the current. And also, in a series circuit, all the components are connected end to end. They are connected one after the other. Why is it so? Because there is only one pathway. There is only one pathway for the current to pass. There is only one pathway allowed for the current to pass. And if a light bulb breaks or is disconnected, the whole entire circuit is going to be affected, because the circuit is going to be open. An open circuit is an incomplete circuit, and therefore current cannot flow. All right, don't forget to send in any questions you may have, or the solutions to any of the questions that were asked in today's lesson at 079 578 2908. Here is a homework activity. Please take 2 minutes to quickly copy down these questions. Welcome back, learners. In our next lesson, we're going to be learning about parallel circuits and other output devices. Until then, thank you so much for watching today's lesson. I thoroughly hope you enjoyed it. Until next time, bye-bye.